All right, get ready because today we're diving deep, really deep this time,
Oh, yeah.
into one of the most mysterious things out there, black holes.
I like it.
You remember that incredible picture that I mean, it was everywhere a few years back.
Oh, the first image ever
The very first image of a black hole
blew my mind.
blew everyone's mind. But today, we're not just going to like stare at the picture.
Right.
We're going to figure out how they even took that picture.
How is that even possible?
Right. What it means about the universe and maybe what it says about us humans, our ingenuity.
Yeah, that's what fascinates me so much about this whole topic. I mean, black holes are literally invisible.
Right.
Like regions of space-time where gravity is so intense, so strong, that nothing, not even light, can escape.
It's like trying to take a picture of Ghost.
Kinda, yeah.
I'm already getting goosebumps and we're just getting started.
Oh, it gets better.
So the stuff we're looking at today for this deep dive goes way beyond just the news headlines. It breaks down not just the science,
Right.
but just the hugeness of this project.
Yeah,
like,
yeah.
imagine coordinating telescopes
All over the world.
from Hawaii all the way to Antarctica,
You need that global network.
all working perfectly in sync
Yeah, if you want to see something that far away.
to get this impossible picture.
Yeah.
But before we get into all that,
Sure.
maybe we should do a super quick, like, Black Holes 101.
Black hole basics, yeah.
Just for anyone who needs a little reminder,
Good idea. At the most basic level, black holes are what's left over when really, really big stars, giant stars, die.
Oh, okay.
They collapse in on themselves under their own gravity.
So it's like imploding.
Exactly.
Yeah.
And it creates this point that's infinitely dense. It's called a singularity,
Singularity. Sounds like something out of a sci-fi movie.
doesn't it? And around that singularity, there's this boundary, the point of no return. It's called the event horizon.
Okay.
And once anything crosses that, even light, it can't escape the black hole's pull.
Oh, wow. So like a cosmic trapdoor, but instead of falling into a pit, you fall into, well, I don't even know, oblivion.
Yeah, something like that.
And are all black holes the same size?
No. They come in different sizes. Some are relatively small, like stellar mass black holes.
Okay.
And then you have the supermassive ones, millions, even billions of times heavier than our sun.
Wow.
And those are the ones sitting at the center of galaxies,
Wait a second. Hold on.
including ours.
Our galaxy, the Milky Way, has a black hole at its center.
Yep, that's right.
Should we be worried?
Not at all. It's so incredibly far away.
Okay, good.
It's more like a galactic anchor.
What do you mean?
Well, its gravity helps hold the whole galaxy together.
Oh,
It influences how stars move and gas across these vast distances.
so we can't see it directly,
Not directly, no.
but we can see what it does to stuff around it.
Exactly, yeah.
Okay, wow. So it's like the conductor of the whole galaxy, but hiding in the shadows?
That's a good way to put it.
All right, now I'm really starting to get why scientists wanted that picture so badly.
Mm.
But how do you even start to photograph something that's, invisible?
That's where it gets clever. They couldn't see the black hole itself, obviously,
Right.
but they thought, what if we could see its outline, its silhouette?
Against like a bright background.
Exactly, against the bright stuff around it.
Like a cat in a dark room and you shine a flashlight.
Yeah, you might not see the cat, but you see the shadow.
You see the shape of it. So they were going for the black hole's shadow.
Precisely.
And what black hole did they aim for?
This one called M87.
M87 star.
Yeah, it's supermassive.
Okay.
And it's at the center of a galaxy in the constellation Virgo, about 55 million light years away.
55 million light years.
That's far.
That's mind-bogglingly far.
It's like trying to photograph a donut on the moon from Earth.
That's a pretty small target from that distance.
Very small.
So what kind of camera lens do you even use for that?
Well, you can't just use any old telescope. They needed something far more powerful.
Okay.
And that's where the Event Horizon Telescope comes in.
The Event Horizon Telescope.
The EHT.
That name already sounds impressive.
Oh, it is. It's not just one telescope.
Oh.
It's a whole network of radio telescopes around the world, all working together.
All over the world.
Yeah, we're talking telescopes in Hawaii, Antarctica, everywhere, all combined.
Like Voltron, the mega telescope.
Uh-huh, kind of. They're making a virtual telescope the size of the entire planet.
They combine telescopes across the whole world. That is some serious scientific teamwork.
Right.
I'm trying to picture this. It's like they used a bunch of little mirrors.
To make one giant mirror.
Exactly.
And they use this technique. It's called very long baseline interferometry, VLBI for short.
VLBI, okay.
So imagine two telescopes looking at the same thing.
Okay.
You time the radio waves, hitting each telescope super precisely.
Okay.
And you use the fact that Earth is spinning, rotating.
Right.
You can basically merge those signals.
Like they were from one huge telescope.
Exactly.
So it's a virtual Earth-sized telescope.
Pretty much.
That's incredible. But even with all that, to capture a black hole 55 million light years away,
Yeah, that's a big challenge.
it wasn't just point and shoot, I imagine.
No. And remember, we're talking radio waves here, not regular light.
Okay.
They spent several nights in April 2017 carefully collecting radio waves from the hot stuff around M87.
Okay.
And this gave them a massive amount of data.
Like how much are we talking?
Hundreds of terabytes.
Terrible.
Like imagine thousands of laptops full of information.
Wow, that's a lot of data. Okay, so they've got mountains of data.
Yeah.
But how do they go from raw radio signals to an actual image that shows us the black hole's shadow?
That's where the real smarts come in.
Okay.
Not just the equipment, but the brilliant minds figuring it all out.
Right.
Processing all that information took sophisticated algorithms.
Like some serious computer power.
Pushing the limits of what was possible.
It's like a giant jigsaw puzzle, but the pieces are terabytes of data.
That's a good way to think about it.
And you need a supercomputer to figure out how it all fits.
Right.
And wasn't there one scientist who was really key to this whole thing?
Oh, absolutely.
Dr. Katie Bowman.
Yeah, her and her team.
Her algorithm was, what, groundbreaking.
Totally. It helped sort through that data and rebuild the image of M87.
So we've got the megatelescope, the data mountain, and the brilliant algorithm.
That's the recipe.
What did they actually see?
Well, it was a moment of truth for science.
Okay.
And what they revealed was amazing.
I'm on the edge of my seat here. Tell me.
Yeah.
What did the image actually show?
All right. Hold on. Okay, so the image, it showed this bright ring of light.
Okay.
It's called the photon ring.
Photon ring. All right.
And it was encircling this dark central region
Oh, okay.
that was the shadow, the black hole's shadow.
It's like, I'm picturing it, a ring of light around pure darkness.
Yes.
It sounds almost poetic, like out of a myth or something.
It does.
So this wasn't just a pretty picture, right?
Oh, no.
This told scientists something real about black holes.
Definitely.
What did it tell them?
Well, for one thing, it was like solid proof.
Proof that they exist.
Yeah, for centuries, black holes were just this idea.
A theory.
Yeah, from Einstein's theory of relativity.
Okay.
But this picture, boom, they're real.
No more speculation.
It was a game changer for sure.
It's like going from, we think they're out there, to here's the photo.
Exactly.
And it wasn't just about proving they exist.
Right. The image actually let scientists study how black holes behave
Oh, wow.
in ways they never could before.
Like what?
Well, how the light bends around the black hole,
Okay.
the size and shape of that shadow,
The shadow.
or the photon ring, how it moves.
Yeah.
All this stuff tells us about the crazy gravity going on there.
So, like, they got a glimpse into this hidden world where gravity is king.
Pretty much, yeah.
You know, we talked earlier about those powerful jets of stuff
Of a jets.
shooting out from galaxies, like from M87.
Yeah, those are incredible.
Did this image help explain how those jets work?
That's one of the coolest things about this whole thing.
Okay.
Those jets, they're so powerful.
Like shooting matter out at almost the speed of light.
It's mind-blowing.
And we don't know exactly how they work.
We have ideas, but this image gave us a much closer look.
At the black hole itself.
Well, at the area around it, where the jets come from.
So, like, we knew the jets were there,
Right.
but now we're seeing the source.
Engine behind
The
them.
launch pad for these cosmic fireworks.
You like that, yeah.
And by studying this image, scientists can start figuring out
How those jets get going. How stuff gets accelerated to those crazy speeds.
Right.
What the black hole's role is in all of this.
It's amazing that we can study this stuff
I know, right?
when it's happening millions of light years away.
It's really remarkable.
So what's next for this Event Horizon telescope team?
Oh, they're just getting started.
Really?
They're always trying to make things better.
Like what?
Better techniques, more telescopes in the network,
Oh, okay.
even better algorithms,
So sharper images.
sharper images, maybe even movies of M87.
Movies. Of a black hole.
That would be something else.
That's wild. And are they looking at other black holes too?
Oh, yeah, definitely.
What?
Well, there's Sagittarius A.
Sagittarius A star. Okay.
That's the big one at the center of our own galaxy.
Oh, wow.
Imagine getting a picture of that.
A picture of the black hole holding our galaxy together.
Yeah, it'll be incredible.
Are there any, like, hurdles to get that image?
Well, Sagittarius A, it's closer than M87,
Okay.
but it's also smaller and less active.
So harder to see.
Trickier to observe, yeah.
The stuff around it changes quicker.
It makes getting a clear image tougher.
But this team, they seem up for any challenge.
They're pretty amazing.
It sounds like the future of black hole research is bright.
You can say that, haha.
All right, so we talked about the tech, the incredible image,
And what it all means.
the mysteries that are still out there about black holes.
There are still plenty.
But I want to go back to something you mentioned about
Yeah.
what this image means for, our understanding of the universe.
Big picture stuff.
Yeah. How has this changed our perspective?
Well, it wasn't just a cool picture. It was a huge win for science.
Oh, yeah.
Because remember, this was the strongest evidence yet that black holes actually exist.
Right.
And everything in the picture matched up with Einstein's theory.
So it's like Einstein's theory passed a test, a cosmic test.
A big one.
What does that tell us about the universe?
It tells us that what we thought about gravity, space, and time.
Based on Einstein's ideas?
Yeah, it holds true even in the most extreme places you can imagine.
And that gives us more confidence in our understanding of the universe.
Absolutely, from how stars are born to how the universe is expanding.
It's amazing that one image can have such a big impact.
It's true.
It's like finding the right puzzle piece and suddenly you see more of the picture.
A perfect analogy.
And it's not just about confirming what we thought we knew. This image has sparked all sorts of new research.
People are working together all over the world, sharing data,
That's awesome.
coming up with new models, pushing the limits of what we thought possible.
So it's a really exciting time to be studying this stuff.
Absolutely, there's so much more to learn.
What are some of the big questions that scientists are trying to answer now?
Well, how black holes grow over time.
Like, do they just keep getting bigger and bigger?
Is there a limit? We don't know yet.
And their role in galaxies?
Yeah, how they shape and change the galaxies they live in.
Right, because we talked about that supermassive black hole at the center of our galaxy acting like an anchor.
Yeah, so they must have a huge influence.
Huge.
And then there's the biggest mystery of all.
What's that?
What happens to the information that falls into a black hole?
Oh, yeah.
We know matter gets, well, basically destroyed when it crosses the event horizon.
Right.
But what about the information in that matter?
Like, is it gone forever?
Or is it somehow saved?
That's a deep question.
It makes you think about the nature of reality itself.
It does. Maybe black holes hold the key to some of the universe's biggest secrets.
Maybe they do.
And now we have the tools to start asking those questions.
It's the first time ever.
This has been quite a journey.
It has.
We've gone from a cool picture to, wow, a deep dive into the science, the implications,
Yeah, the mysteries.
mysteries that are still out there about black holes.
Lots of them.
And I think we've all come away with like a sense of wonder
For sure.
and wanting to learn more.
That's what it's all about.
We've only just scratched the surface of this black hole stuff.
It feels that way.
But before we go any further,
Okay,
let's pause here for a minute,
take a breather.
because this is where things get really interesting. Okay, we're back.
Back for more.
Ready to wrap up our deep dive into, well, black holes?
It's been a wild ride.
I don't know about you, but my head's still spinning from all this mind-blowing stuff.
It's a lot to process, for sure. But I think it shows how curious we are. As humans, I mean, we want to understand the universe.
It's true.
We went from, like, imagining these invisible things out there
Right.
to actually seeing one.
Thanks to that amazing telescope.
The Event Horizon Telescope, it's a marvel.
It makes you wonder what else we might achieve. What other impossible things we might be able to do.
That's the thing about science, isn't it?
Yeah.
Every answer just leads to more questions.
Yeah.
And with the universe, there's no end to the possibilities.
So we still got a lot to learn about black holes.
Oh, yeah. Tons.
What are scientists focusing on right now? What's next?
Well, the EHT team, they're not slowing down.
Okay.
They're always making the technology better.
So even better pictures.
Even better pictures, maybe even more detailed movies of black holes.
Movies. Wow.
That would be something.
It would?
But it's not just about the pictures, right?
Right.
Scientists are trying to understand the physics happening around black holes.
Oh,
Yeah.
with like models and simulations.
Yeah, trying to figure out how it all works.
I bet that's tough. Those are some extreme environments.
You're not kidding. One thing they're really looking at are those accretion disks.
Oh, the stuff swirling around a black hole.
Exactly, those clouds of gas and dust that feed black holes.
The cosmic buffet.
Yeah, something like that.
And what are they trying to find out about them?
How they form, how they change over time, how they help black holes grow.
And those jets of plasma,
Oh, the jets.
the ones shooting out from the poles of black holes.
Those are a big mystery.
What are they trying to learn about them?
How they get launched, how they stay so focused, how they affect the galaxy around them.
Because they do affect the galaxy,
Like,
right?
yeah, big time.
Yeah.
They can shape the whole evolution of a galaxy.
Wow, so black holes are more than just like sitting there sucking things in.
Much more. They're active players in the universe.
They're shaping the galaxies they live in.
Yeah, it's pretty amazing. You know, something I've been thinking about,
Yeah.
those smaller black holes we talked about.
The stellar mass ones, right?
Yeah, are there any of those, like, in our neighborhood?
Here in the Milky Way.
Yeah,
Wow, good question. And the answer is there are
millions of them scattered throughout the Milky Way.
millions.
It seems like a lot.
Should we be worried about running into one?
No, not really.
Okay.
Black holes, no matter how big they are.
Yeah.
Their gravity works just like anything else with mass.
Okay.
It's only when you get too close to that event horizon
Right. The point of no return.
that things get really crazy.
Okay, good to know. But it really shows you how vast and diverse the universe is.
It really does.
So many things out there just waiting to be discovered.
That's what keeps me going.
Me too.
Every new observation, every new thing we find out, it brings us closer to understanding.
Understanding the universe, the laws of nature, how it all works.
Yeah, and our place in all of it.
I think that's a great place to stop.
A good note to end on.
We started with a picture.
And look how far we've come.
We've learned so much about black holes, the universe, even ourselves.
It's been quite the journey.
I feel like we've all come away with a sense of wonder
A sense of awe.
and wanting to learn more.
That's the spirit.
So to everyone listening, keep looking up at the stars.
Keep asking those big questions.
Never stop being curious.
The universe is out there, waiting to be explored.
There's always something new to discover. Until next time, keep exploring.